So this lesson is going to teach you how to do solving exponential equations that require you to take the log of the equation. And this is going to be for half-life equations, like this one right here is the half-life equation, and for compound interest. So on this half-life equation, this is the basic setup, where 0.5 is the half-life. Y is the final amount, A is the initial amount, just like they've always been on our exponential equations. And T is time, and H is the time for a half-life. And so here's our story. Element X decays radioactively with a half-life of 7 minutes. If there are 330 grams of element X, how long to the nearest tenth of a minute would it take the element to decay to 58 grams? And so here's our values. The final amount is 58, the initial amount is 330, and the half-life time is 7 minutes. So we just plug those in, and I end up with this. And so now that I have my equation, it's obviously exponential. And so I'm going to go over here to my steps I had before, which is first circle the part that has the exponent. Again, this isn't required, it's just to help you understand which piece do I need to get by itself, which piece am I solving for. So the part that has the exponent, of course, is the 0.5, and this is the part I need to get by itself. So everything not in the circle I have to make go away. And so I had to get rid of this 330. Well, what's the 330 doing with this? It's multiplying. So how do you undo multiply? You divide. So we're going to divide both sides by 330, and that's going to give me this fraction right here, 29 over 165, or you can get an ugly decimal. Now that I have isolated that circled part, when you've done that, you now have base of an exponent equals a number. And so now we just convert it into log form. And the log form is when you switch these two places. This becomes the base of your log, and these two switch. But this is written backwards from what we're used to. We're used to having the exponent part on the left and the number part on the right. So I rewrote it like this. You don't have to, but I rewrote it like this. And these two are the two that are going to switch places. So again, log base 0.5, and then the t over 7 and the 29 1/65 switch places. And now that they look like this, now that we've done this log part, the next step is to get a base that we can work with. So log base number, the change of base formula, is log of the number over log of the base. So this is going to be log of the number, which is 29 over 65, over the log of the base, which is 0.5. I put that in my calculator and I get an answer. And the answer is 2.50834. But sometimes you still have to solve for the variable. This does not equal t, it equals t divided by 7. Well, how do you undo divide? You multiply. So if I multiply both sides times 7, I get t equals 17.558-ish. But I need the nearest tenth, they said. I'm sorry, I didn't finish it. Nearest tenth of a minute. I must have lost a section. So the nearest tenth of a minute would be 17.6. So let me just add that on there real quick. 17.6. And there's your time. There we go. All right, let's try a compound interest problem. So here's your compound interest formula. Again, A is the amount after time, the final amount. P is the initial amount, the principal, the money you put in the bank. R is the interest rate as a decimal. N is the number of times you do it per year, and N is in two different places. And T, of course, is the time. So if a person invests $10,000 in a bank, that's how much money they put in, that's their initial amount. And the bank pays 5.5% interest, which we need to write the interest rate as a decimal, so I'm going to move the decimal two places. So 0.055. Compounded monthly. So the time is every month, and there's 12 months in a year, so N is 12. To the nearest tenth of a year, how long would this person leave the money in the bank? Until it reaches $27,400. Well, let's look at our numbers. The final amount is the $27,400. The initial amount is the $10,000. The interest rate as a decimal is 0.055. And the number of months, N, is 12, rather. Not the months, but N is 12. So if I set the equation up, it looks like this. Final amount, initial amount, interest rate, 12 months, time is unknown. And so now I have my equation. I'm going to circle the part that has the exponent, which is this great big parentheses part. So who's not in the parentheses? The 10,000. That's the part I need to get rid of. How do you get rid of times 1,000? With a divide by 1,000. And that gives me this, 2.74. So now that I have it in this form, which is base to an exponent, base to the exponent equals a number, equals 2.74, I'm going to convert it into a log. But again, this is written backwards from the way I like to see it. I like to see it like this so that I can see that these two are the two that switch places. So this is your base of your logarithm. So log base this thing. Now, of course, you can change that into a decimal, but it's really long and ugly. And your calculator doesn't need you to change it to a decimal. It's fine with that. So log base the parentheses part, the 2.74, and the 12t switch places. So now I have just a single log. I'm going to now evaluate that log by doing the change of base formula, which is log over log of the base. And the base is the parentheses part. So log of 2.74 over log of that parentheses part equals 12t. I use my calculator, and I find out that log over log is 220 point, It equals 12t. Unfortunately, I have not solved for the variable. The last step is, if needed, solve for the variable. So how do you get rid of the 12? Divide by 12. And so my final answer is 18.3685, but they said the nearest tenth of a year, so 18.4 years. And there you go.